Alright guys, welcome to this page of the notes, and here we go. Let's try one more of these really kind of nasty looking problems just to make sure we've got the process down for how these go. Again, I'm going to be adding fractions in the top, subtracting fractions in the bottom. I'll try to keep them as simple as I can. And in this case, this one's really not bad. The denominator is b, so I'm going to need a b in the denominator. This one, so I'll just multiply top and bottom by b. In the bottom, the denominator is a. So I'm going to need a denominator a here as well, and that just means multiply top and bottom by a. So let's go ahead and take care of all of that so that I have a over b plus 1 over 1 times b over b. In the bottom, it's going to be 1 over 1 times a over a minus b over a. Alright, again, the reason I'm doing that is now my common denominator is going to be a. Here my common denominator is going to be b. I'll then be able to add the fractions in the top and subtract the fractions in the bottom. So what we wind up with is a over b plus b over b. In the bottom, a over a minus b over a. Fantastic. So we did exactly what we set out to do. I have my common denominator to b. I have my common denominator of a. Go ahead and add the fractions in the top, subtract the fractions in the bottom. I wind up with, oh, sorry, I need my pen, a plus b over b divided by a minus b all over a. And again, just like the previous two problems, you take care of the fractions in the top, take care of the fractions in the bottom, and you wind up with a complex rational expression just like we took a look at in section 1 of this chapter. Keep the top, multiply by the reciprocal of the bottom. I'll write it right here so you can see how it works. I keep the a plus b over b, keep the top, division becomes multiplication, and I multiply by the reciprocal of the bottom, which is a over a minus b. In the previous two example problems, I then had something that cross-canceled. In this one, I don't. So you wind up with a times the quantity a plus b. So a times a plus b, divided by b times the quantity a minus b. Again, in this case, there's going to be an infinite number of possibilities for restricting the domain because I have a minus b, right? But when those variables are added or subtracted, there's an infinite number of possibilities that could get you to 0 in the denominator. So we'll just ignore restricting the domain, keep your final answer, simplified form. There's nothing else that you can factor out. All right, guys, hopefully at this point we've done 3 of them now. You kind of got the hang of the process that you've got to go through, even though the problems may change. And again, I'll try to keep them as simple as I can when it comes to finding those LCMs. Give them a shot on your own, practice some, whether you got a book with you or homework or whatever, give them a try. I got one last kind of problem that I want to look at with you guys when it comes to actually finding ordered pairs. Head on over to the next page of the notes, and I'll meet you guys there.